Hello friends, today we have discussed about binary search. So here in the previous class we discussed about the linear search, but the linear search there each and every element we search and we find out that one particular element is present in the list or not. But in the binary search what we are doing, we divide the list into two parts and then we search the left portion of the list and then the right portion of the list. Okay, so before that, so what we are doing, so in the linear search we search each and every element, and it is not mandatory that if we search in the sorted list or we search in the unsorted list. But here in the binary search, the first thing we are doing it is as we sort the list as either in ascending order or in descending order. Okay, so suppose the input here we are using any type of sorting and we sort the list as in ascending or descending order. Okay, so suppose here this is one list 5, then 8, then 12, 14, 17, 20, 25 and 30. Suppose this is the list and here we sort the list in ascending order. Okay, and the name of the array is here A, and we write down like this, like the array we write down all the values here. So this is the indexing. Here we write down 0, 1, 2, 3, A4, A5, then A6, then A7. So how many number of elements here? 0 to 7, that means 8 number of elements are here. So whenever we using the binary search, we first divided the list into two parts. So whenever we divide the list into two parts, that means how we divide it? We write down mid equal to, okay, then begin plus end, then divided by 2. Okay, so what do you mean by begin and what do you mean by end? Here this first position is taken as begin and the last position is taken as end, and we divide our list into two parts. Okay, and we are getting one mid position. Okay, and whenever we are getting our mid position, so that mid position element, if it is equal to that searched item or not. If we directly found that the mid position element is the searched item, then the search is successful, and then after we exit from the particular algorithm. Okay, then suppose we are not getting the mid position element is the searched item, then what we are doing? We compare that mid position element if the mid position element is less than the searched item or it is greater than the searched item. Okay, if it is less than the searched item, then what we are doing? We here search the left portion of the list. Okay, from the mid we search the left portion of the list, and if the searched item is greater than to that mid item, then from the mid we search the right portion of the list. Okay, so how we are doing this? Suppose here this is one example, and the searched item here is suppose it is 20. Okay, so how we find out that the 20 is in the list or not? Okay, so this thing is written mid equal to begin plus end divided by 2. Okay, so that means the mid is equal to begin is here 0 plus end is here 7. Okay, 0 plus 7 divided by 2, which is here we find out 3.5, and we are taking truncate it and we are getting the 3. Okay, either you are taking the 4 or you are taking the 3. Okay, so here the 3 position element, that means A is the name of the array and the 3 position element, if it is equal to that item or not. Okay, so we first search it that if this is equal to that item or not. If this is equal to item, that means our search is successful and we are getting our result. Okay, but here the searched item is 20 and the A3 element is 14. Look at that example, here it is 14. Okay, that means we are getting that the mid position element which is 14, which is less than to the searched item. So our logic, what it says that if the mid position element which is less than the searched item, then what we are doing here, we search the right portion, that means the right side of the list. Okay, and from that right side, which is the first element, we are taking the mid plus one element as the first element, as the beginning element, and the end is as it is. Okay, so after that what we are search here, mid plus 1 is the begin here. Okay, we are taking the begin as begin is equal to mid plus 1, which is here, what is the value here, the begin is equal to, okay, so mid is here 3, mid plus 1 is 4, is it so or not? Okay, next is end is as it is, and it is 7. Okay, so what we are doing here, we just add this begin with the end and divided by 2. That means begin plus end then divided by 2, which is the next mid position. Okay, so next mid is equal to begin is here 4 plus end is here 7. Okay, then divided by 2, which is 11 by 2, which is 5 point something, and here we are taking the mid position element as 5. Okay, then we check that if the mid position element is equal to that of the 25 or not. Okay, sorry, it is 20, not 25, 20 or not. Okay, so here the searched item is 20. Okay, and here mid position is 5. So 5, A5, here it is 20. That means we are getting our searched item. Okay, that means the search is now successful. Okay, and suppose this is not your 20. If suppose it is 25. Okay, so what you are doing? So now the mid position element is not equal to that 25. So it is equal to 20. It is not equal to that 25. Okay, but here we are getting what is the value? The mid position element is less than that of the 25. Okay, so whenever it is less than that of the 25, so the next position here we are taking as the beginning. Okay, so next we taken, this is the mid position na, A5. So we are taken the 25 as your next begin. Okay, so once again we write down the begin is here mid plus 1, which is here equal to 6. Okay, and the end is here equal to once again the 7. Okay, so we are getting the mid is equal to begin plus end divided by 2. Okay, so then after we find out begin is here what, 6 plus 7 then divided by 2, which is here it is 13. Okay, divided by 2, that means 6 point, and we are taking as 6. Okay, so here we are getting the mid position is 6. Okay, and the 25 is the searched item and we are getting our searched item. Is it clear to all of you? Okay, so what here basically we are doing, we just take the mid position as the beginning plus end divided by 2, and we divide our list into 2 parts. Okay, then from which part we are getting our next element, we search that if the mid position element is less than the searched item or it is greater than the searched item. Suppose it is the searched item is 8. So what we are doing here, the mid position we are getting here that it is 14. Okay, So we searched left side of the list. We are not searching the right side of the list because the mid position element here it is greater than that of the greater than that of the searched item. Clear? So in this way we search in the binary search. Okay. So next we write down the algorithm for the binary search because this is a data structure subject, so we write down algorithm for each and every case. Okay, so here you write down the algorithm. So what is the algorithm and how you write down that algorithm? Step 1, step 2, what is the procedure, how we write down it. So look at this carefully, we observe that how we write down that particular algorithm. Okay, so first the name of the algorithm. In the previous case also we mention here the name of the algorithm, and here basically what we are doing, you write down the name of the array. Then here we are taking the lower boundary, okay, and upper boundary. Okay, so next is item, which item we want to search. Then another is location. Okay, suppose in that particular location we find out our element, so we write down all these things. So first we write down step 1. Step 1, look at this how we write down our algorithm. Step 1, listen one thing here, I forgot to write down the values, whatever be the values we are taking here. Okay, just carefully write down these things because here we particular mention that what is the value of a, what do you mean by lb, what do you mean by eb, item, loc. So all these things are here writing. In the binary search we also writing all these things, and here also we write down all these things. So here we write down here a is a sorted array. A is a sorted array. Okay, so listen carefully. Here it is written directly that A is a sorted array. Okay, that means we are taking the array as a sorted. Okay, so LOC here in the above we write down sorted array with low boundary. Here low boundary LB. The low boundary is taken as LB, and upper boundary here upper boundary is taken as UB, and item is the searching element. Okay, and here the variable different variables here we are using the variable. Okay, begin BEG, then end END, and mid MID, used for the beginning, For the examination point of view, it is important that you write down and explain all these terms whichever used here. Okay, so end and middle locations is end and middle locations of the list. The variable begin and mid used for the beginning, end and middle location. Okay, so all these variables things here we are using. Okay, so next, this is all about the detailed descriptions. Okay, so next what we are write down, we just begin our algorithm and we write down here step 1 start. We know that in each and every algorithm we write down the start and exit or start and end. Okay, so step 2 set begin B is equal to lower boundary. So already I told these things that whenever we write down any starting position, it is the lower boundary, and here we mentioned that lower boundary is the begin. Then end is upper boundary. Okay, and mid, how you decide the mid here? Mid is equal to, okay, so here we taken it as integer because we are not taking any float value. Okay, so we write down begin plus end, okay, then divided by 2. Okay, so this is one bracket, this is another bracket. In our programming structure we write down that algorithm. Then in the step 3, so what we are write down? Repeat step 4 and 5, step 4 and 5. So how many times you repeat it? While begin is less than equal to end. Here the begin is less than equal to end, and 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 a mid is not equal to, either you are write down in the algorithm style or you are write down in the programming style, whatever may be, you are write down not equal to like the programming style, not equal to, okay, item. So how many times you repeat the step 4 and 5 while begin is not less than equal to end and a mid is not equal to item. Okay, so that means begin, whenever the begin is at the end position, okay, we finished it, or we find out whenever we are not up to whenever we are not finding that item, we are not finished our algorithm. Okay, so next step 4, we write down here if item is less than, if item is less than a mid. Okay, so already I told these things that whenever the particular item we want to search, okay, if it is less than or if it is greater than, whenever it is less than, then what we are doing? If it is greater than, and then what we are doing? Okay, so whenever the item is less than a mid, so what we set here? We set the starting and ending position. Okay, so if the item is less than a mid, okay, then we set our end is equal to mid minus 1. Why it is a mid minus 1? Because our item we searched which is in the left portion. So whenever it is in the left portion, then starting is as it is, but end is mid minus 1, because we already know what is the mid value. After that we writing these things. Okay, so else if this is not happened, then what is the next value? Next we set begin equal to mid plus 1. So there are two cases, either the item is less than the mid position element or the item is greater than the mid position element. If it is less than the mid position element, the starting is as it is and the end is mid minus 1. If it is greater than the mid position element, then the beginning is mid plus 1 and the end is as it is. Okay, so next is step 5. So in the step 5, what we are write down? Mid equal to set mid equal to, okay, so mid equal to here integer begin plus end divided by integer begin plus end Okay, divided by 2. Okay, so why we are writing like this? We are already writing these things here. Mid equal to begin plus end divided by 2. So why once again we writing these things? Because our end and begin position is now changed. Okay, so in this step our end and begin position is changed. If the item is less than, the end position is this, and the previous end position is different. Okay, and if our item is not less than, then our beginning position is different, which is mid plus 1. Okay, so next, what is our beginning and end position? We add it and we divided by 2 to find out the next position, next mid position, because each and every case we search that if the particular item is in the mid position or not. We first compare it with the mid position. Okay, so I just delete this above things, which is the description of about all the concept, that means whatever be the values and variables we are taking here, we just delete it. Okay, so I am here erase this thing and write down the next algorithms, whatever remaining algorithms are there. Okay, so after step 5 we are writing here step 6. Okay, so what do you mean by the step 6 and why? Means we write down the step 6 because our algorithm is not end here. We just find out the mid position. Then after what we are doing, we search it. Okay, if a mid is equal to item. Okay, that means we are getting that item. Okay, so then what we are doing? Then here we are using the location part. Then LOC, set LOC means location. LOC is equal to mid. Why we writing that LOC equal to mid? Because that particular element is in that particular location. Okay, else set LOC equal to null. Okay, so why we writing here null? Because we are not getting our result, we are not find out our element. Okay, that means after finally we know that whenever we are search for each and every mid position, but we are not getting our result. Okay, so here I am explain once again this thing by one simple example. Okay, so this is one list. I here expand this list. Okay, so here it is 5, 6, 9, 11, 15, 16, then 20, then 28. Okay, suppose this is the list and this name of the array is A and 0, 1, 2, 3, 4, 5, 6 and 7. So what we are doing here? We start our algorithm and begin, we start here, write down the lower bound which is here 0 and the upper bound which is end, we store it, and we find out the mid position which is lower plus upper divided by 2, which is 0 plus 1 divided by 2, which we are getting 3.5, and we are taking here as it is integer, so we are taking here 3. Is it so or not? 0 plus 7, 3.5 here divided by 0 plus, here 7. 0 plus 7 divided by 2, which is 3.5, and we are taking the integer value 3. Okay, and next we write down repeat step 4 and 5 while begin is less than equal to end and a mid is not equal to item. That means we repeat this step 4 up to how many times we repeat it? We repeat it up to that value is 4 and 5. Okay, not only 4, we repeat 4 and 5 while begin is less than equal to end. Okay, so that means the begin whenever it is not less than equal to, means less than, up to less than, we also search it. Whenever it is equal to, we end our algorithm. And a mid is not equal to item, so whenever we are find out our item, we just stopped our algorithm. Okay, so then next in the step 4 what we write down? If item is less than a mid. So here suppose we search for 9. Okay. So the searched item is here equal to 9. Okay. So what we are doing here? We search that if the item is less than a mid. So here mid position is here 11. Okay. And the searched item is less than. If the item is less than a mid. So here this condition is satisfied. Set end equal to mid minus 1. So mid position is here. Okay. And mid minus 1 is here. That means what is the mid minus 1 value? 2. Okay. And here else part is not executed. Why it is not executed? Because if part, if it is satisfied, then we are not executing the else part. We go directly to this. If set mid equal to integer begin plus end divided by 2. So here we know that the begin is here 0 as it is, but the end position is changed to mid minus 1, which is now 2. So next 0 plus 2 divided by 2 is the next mid position. Okay. So 0 plus 2 divided by 2, what is the value here? 1. Okay. So if it is 1, then what we are doing? Okay. We search that if a mid is equal to item. Okay. So how much we repeat the process here, it is written that step 4 and 5 is repeatedly we are doing. Okay. Up to whenever the a mid is not equal to item and the begin is not equal to less than equal to end. So whenever we find out the value of a1 is equal to here this 6. Okay. So once again we repeat the step 4 and 5. Okay. If the item is less than a mid, here now the mid position is 6. Okay. That means it is not less than the mid value. Okay, the item is 9, so it is not less than the mid value. So the if part is here now not satisfied. We are going to the else part. So the else part, the begin equal to mid plus 1. So begin here we are taking mid plus 1, and now the mid value is what? The mid value is 1. Okay, and we set the begin equal to mid plus 1, which is 1 plus 1, which is 2. Okay. So the begin equal to now here 2, and set mid equal to begin plus end divided by 2, and begin is here 2, and previously what is the end here? The end is here 2. Already the end is there 2. We are not changing the end. Previously the end is 2 there because it is mid minus 1 in the previous step. So 2 plus 2 divided by 2, which is the value? This is the second position. Okay. So now we are getting the mid position is equal to the second position, and we know that this item is present in the second position. So our search is successful. Okay. So how do you know that our search is successful? Here set mid equal to begin plus end divided by 2. That means the second position item we are getting. And if the item is less than a mid, so it is not less than a mid. Okay. So the item is exactly the particular means the particular that position element. And how many times here we are repeat this process? Look at this. Here another thing is written that in the step 3 repeat steps 4 and 5 while begin is less than equal to end. Okay. So here the begin and end less than equal to, but here both are equal to. So we stop our algorithm here. Okay, it is not less than now, it is equal to. After that the begin is greater than the end. Okay, so we stop our algorithm here, and a mid is not equal to that item. Okay, so here this condition and this condition. Okay, so both the condition here satisfied. So after that we are going to the step 6 because the step 5 or 4 we are not executing now. So if a mid is equal to item, so whenever we are getting this type of situation, begin is less than equal to end and a mid is not equal to item, we are finding our item. So if a mid is equal to item, then set location equal to mid. That means in that position, in that location we are getting our result. So the location is here equal to Okay, so we are getting our location, and that location value is equal to where we are getting our particular item. Okay, so else set location equal to null. Suppose we search the list and the item is not in the list, but this condition is satisfied because the means starting is equal to that end. Okay, so and we search it and we are finding that the item is not in the list. Okay, so in that situation the else condition is satisfied, else set LOC equal to null. Okay, so like this, and then after exit. Like this, we searched in the binary search that particular item is in the list or not. We divide the list into two parts, and in each and every step we divide it and we searched it. That's why it is called as binary search. Okay, so in each and every case we search the location of the middle location, and we here compare that if the element is in the middle element or not. If it is the middle element, then the search is successful. Otherwise we are going to the left list or we are going to the right side of the list. So this is all about the binary search algorithm. Thank you.